Well, hello everyone, and welcome to another video by Fitness Technology Services. Today's video, well, it's another by request video. Basically what we're going to do is we're going to test your Sole motor just to see if it runs. A lot of times you'll get this request even from the manufacturer. If you call it an issue with your belt not running, it either can be the controller or the motor. So the easiest thing to do is test the motor, and I have another video on doing this where you can do it with a 9-volt battery. I'll add a link to that. But I'm just going to do it with my my 12-volt drill battery right here. Then I'm going to show you how to meter the motor so that you know more accurately that it's working well. Alright, this will just make sure that it's spinning, which of course is a good test to do. I'm also going to do it with these little bread ties here, just because in case you don't have little add-on lug connectors like I do, then you should be able to do this with just your household bread ties. One is actually a piece of wire I found laying around from old telephone cable, but it'll work. Alright, so I'll need my glasses for this. First thing you're going to need to do is disconnect both your motor wires. So I've only done one so far. I'm going to do the other one now. But a lot of times on the newer models from 1218 up, there's a little clip right here, and you got to kind of press this little clip in. Oh, by the way, make sure it's unplugged. Don't do this plugged in. Alright? And if you do, it's not my responsibility. I'm telling you, unplug it. So anyway, a motor is a DC power source. Typically they go 1 mile an hour for every 10 volts DC that they get. So this should clearly, we're going to guess at this being 1 mile an hour because it's a 12 volt battery, maybe 1.2, but I don't think it's necessarily that accurate. Alright, so it's a simple little test. I've got my little leads bent over to where it's going to hopefully make good connection. I didn't do this one yet. So we're going to do that now. Just going to bend this over right here like this. Might not even need to do this, but I want to try and keep it from falling out as much as possible. We'll use the blue for red. And if you hook your motor up backwards, it will just spin backwards. Don't do it for a long time though, because some of these motor pulley heads are connected by being turned, twisted on. It's basically just a big nut. Some of them have a keyway in it and it's pressed on. You worry less about that. But if it's running backwards, just don't run it for long. But it's not going to hurt anything to run it for a couple of seconds. Alright? So I'm going to put the black in with the white, and I'm just going to place it down inside my battery. Then I'm just going to touch the other side because I don't really need it. See, that's not working. Let's try a little better. There we go. Didn't have a good connection. And I got it running the right way. So I don't know if you can see that or not, but that looks like it's basically going 1 mile an hour. Alright? So I'm going to do my next little thing. I'm going to zoom in a little bit. So that means my motor's running good, basically. Or at least passes the step 1 and running good. So I'm going to disconnect these. Now, for my next little trick, I am going to use my connectors because I don't want it to, well, let's see if I can do it direct, actually. Where is my meter? Here's my meter leads. Black is probably common, wouldn't you think? Red is probably not coming. Oh yeah, I got plenty of room. I don't need to use those extenders at all. Alright, so we're going to plug this into here. Plug this into here. So basically, like I said, for every 1 mile an hour, it gets approximately 10 volts DC. So let's, hopefully I don't mess that up for you guys where we can see that. So I'm going to take a half a second break here, turn this back on. Then I'm going to zoom in close where you can see it. So I'm going to set this on DC because it's a DC motor. And when I walk on this, we should produce anywhere from 10 volts DC to 20 volts DC maybe 25, depends on how hard I want to walk on it, really. Alright? Alright, so here's the second half of this test. So, if my theory is correct, I should produce 10 volts DC for every 1 mile an hour that I walk. I kind of know 1, 2, 3, maybe 4, but I'm not going to run any faster than that because this is kind of hard to do without the motor. You can do it, and it's actually a pretty good workout. It has a lot to do with the quality of your belt. If your belt is really slick as it goes by, you can run on it really without it. If it's not, then it's really a lot of labor to do. But anyway, for our test, it doesn't really matter. Let me make sure I'm on DC, which I am, millivolts, DC. All right, so I'm going to go over here. I'm going to walk on my treadmill. Now, I won't be able to see this, but since the meter keeps jumping around, and I've had to do this 3 times today, which is really hard to do, I'm pretty sure now that this is working. So I'm guessing this is between 12 and 22 volts DC. I'm not going to make it go faster than that because, as you can see, my meter is suspended and it shakes a lot and you can't get a really good visual. So you're going to have to trust me on the higher speeds. I'm assuming this is somewhere around 25 volts DC. But at the same time, a lot of video today. At the same time, this is showing that our motor not only works off of a DC battery, but it produces the correct amount of voltage. So I think in this particular case, our motor's perfectly good. Well, anyway, that's all I have for you today. If you could, please subscribe to my channel. I appreciate you viewing. I appreciate any support that you give me. And that's it for today. All right, thanks.